So I've got beta, and hi, welcome to PreCalc 4.1 day 4. We're gonna clean up the notes that I skipped. I skipped the example 6. I think it was on page, I don't know, one more page, page 4. Thanks, guys. It's on page 4. Um, it's funky. Why is it funky? The funkier stuff is, it looks scary. It's still the same method that we've been working on, okay? I don't want it to be shocking or strange, and I'm up here without a calculator, so I'm gonna grab a calculator real quick. But as we read through, and maybe I should have you guys do this for yourselves, you have beta. It is negative 265.363. I want you to draw beta in standard form, okay? And that means you're going to take it from the x-axis that's between the first and fourth quadrant and show me what that angle looks like. So go ahead and do that right now. Draw beta, okay? And I'm just going to put my axis up and wait for you guys to finish drawing your beta. Because at this point, we kind of know the direction of positive, negative on our axes. Now, since beta's negative, I'm going to use red, and I'm going negative 265, which is, if I can get my glasses on, because my eyes are tired today, I can't see anything. That's negative 265.363 minus 180, excuse me, plus 180. So I get the result. So 85 degrees. So I'm looking at like right here. So I got this is going here. This is my negative 265.363 degrees. This is my beta. Are you okay with that? Okay. Are you okay that it went around clockwise from my standard position, which is my x-axis going to the right, or the axis that's between quadrant 1 and quadrant 4? Now, the next thing, that was A. Okay. In B, find the reference angle, beta reference. Beta reference is the positive angle made, let me get a different color, the positive angle made between the closest x-axis and the terminal ray. Does that make sense? So find your beta reference. And we're going to talk about beta reference next. Okay, so find your beta reference. Now, what sign should your reference angle have? Should be positive, okay? And remember, my beta reference is really all about the absolute value, of 265 plus 180, okay? So I just added 180 to both sides and I got that 85. So that's where 85.363 degrees comes from. Are you okay with that? That's my beta reference. Positive angle made between the terminal ray and the x-axis. Are we okay with that? So if they ask me to find the reference angle, that's B, I'm done. In C, find the coterminal angle, beta coterminal, to beta, that is 47 positive rotations away. And people are like, what? Okay, let's talk about it. If I'm a snowboarder and I spin around once, how many rotations is that? 1. How many degrees is that? 360. We're working with degrees. If I do it twice, it's 720. If I do it 3 times, are you starting to get this? 3 times 360, 4 times 360, 5 times 360. Right now, I have a negative angle. I want to know a coterminal angle 47 positive rotations away. Okay, so I'm going to go in a counterclockwise manner 47 times. So I'm going to add to negative 265.363, 47 times 360. That's what they're asking me to do. Does that make sense? Okay, reread the question and then find our solution. And I've got to get my glasses on again, run my calculator. So in C, I'm talking about the fact that I've got my beta plus 47 positive rotations away. Are you okay with that? So I should have an answer. One can only hope. Sorry, I looked down and I scrunched all my numbers. So we're going to write them better. By the way, this is beta coterminal. It is an angle that ends in the same spot that beta does. Are you okay with that? Feeling okay? That's C. In D, I want you to convert beta, beta ref, and beta coterminal into DMS notation. And I want you to do it by hand, not using your calculator, okay? As a reminder on how to. And some people are like, what? So let's review. I'll do this one first. And D, so if I go, well, I'll do them in order. That makes, no, I'll do them in reverse order. That'll be fun. So I got beta coterminal, okay? So if I got beta coterminal, this is 16654.637 degrees. Now remember, in DMS, the D is the stuff on the left side of my decimal, okay? The M is minutes. And when I'm doing it, I know there are 60 minutes per degree. So 0.637 degrees, and there are 60 minutes in 1 degree, and I'm going to multiply those. So I got 0.637 times 60, and that's 38.22. Now remember, that's minutes. Now, right now, my DMS that I'm working with is, I don't know if I'm going to have enough room here. We'll pop it down here. So in DMS, if I have to, we'll slide it down. I got 6654 degrees, 38 minutes. Now I need seconds. And seconds and minutes, we got to be thinking about that. So to go to seconds, I got 0.22 minutes. I'm going to make seconds. Well, there are 60 seconds in 1 minute. Okay, so now my minutes cancel, and now I get that 0.22 times 60. So that's 13.2. So now that equals 13.2 seconds. Now, I just did something by hand, and I kind of showed you all how to do this, right? To put it in DMS. So now check your work. I forgot which direction everything goes, so let's see what's going on. And second angle, go to DMS, hit my answer, and whew, it's right. Okay, so that's the first one. Now, you guys do the last two. What's beautiful about the last two is that they're one of them's coterminal, so I've done the work for the last part for you already. The other one is a reference angle, so you're gonna have to do a little different work, okay? But go ahead, find them right now. Take the time, get those DMS on. You should be able to do it calculator free. Do it, and then check with your calculator. Don't do with your calculator, okay? Any questions about how I'm doing it? It's all about unit conversion stuff. I'll turn folks off at home. You guys get it done. Again, when we're doing this beta reference, okay, I'm already starting with the fact that 85 degrees is my degree. I'm really worried about 0.363. And remember, the issue here is minutes, degrees. And there are 60 minutes in 1 degree. Okay, so 60 minutes in 1 degree. Okay, so I've got that 363. Sorry, I'm gonna have to have these surgically implanted in my head and remember to have them on all the time. I got 0.363 times 60 is going to give me 21.78. Remember, that's minutes. And so now I've got 21.78, 21 minutes. And now I take that 0.78, I got to find seconds. And there are 60 seconds in 1 minute. So I take that 0.78 times 60, and I get 46.8. And I get 46.8. The beauty about all the work we just did is the next one's already done. How you doing? Is it okay? I got some stares. I got some head bobbles. I got some stares like, do we have to do that? How did I just get this right away? Okay, keep in mind, always with DMS, I start out with my degree, okay? And I did the work with 363 already. And that's where it's coming from. So I didn't have to do anything else on the other stuff. It just kind of flowed out. And it's because my reference angle is in the same direction as my original beta. Even though it was negative, it's coming down there. So that's why I was able to let you just do it once. Okay, does that make sense? Okay, so that was that example that we didn't do. My other concern I started yesterday is numbering the unit circle and being familiar with where things are when we're talking about it. So if y'all wouldn't mind to, I don't know, hang out and recognize that an old guy kind of wants to do some stuff to help you out. We need some, just grab a piece of notebook paper and open it up. We need a blank sheet. Don't rip it out, just leave it in your notebook because we're going to use it as a sketch piece. Maybe. Okay, first of all, I got to get a circle here. Okay. When I'm looking at a circle, when we're talking about the unit circle, let's talk about the first thing. I've got pi, I've got 0, and I also have 2 pi. We talked about yesterday that half of pi is pi over 2, and that half of pi, pi over 2, is up here. Well, if I can count by pi over 2s, let's count by pi over 2s. 1 pi over 2, 2 pi's over 2 is pi, 3 pi's over 2, right? So I've got this as 3 pi over 2 down here. This is 3 pi, and maybe I should bring that up a little bit. I don't know if that's going to work or how that's going to be. Yeah, good. So I've got 3 pi over 2 right there, and I got 4 pi over 2, which is just, again, 2 pi. Are you okay with counting this by pi over 2s? Okay, so I've gone pi over 2. Let's go pi over 3. So pi over 3 is a third. So if this is pi over 3, this is 2 pi over 3. This happens to be 3 pi over 3, which is just pi, okay? And down here I have 4 pi over 3. And then I have 5 pi over 3. And then I have 6 pi over 3, which is the same as 2 pi for 1 revolution. Did you notice that those pi over 3s are kind of grouped around the y-axis? Okay, pay attention to that pattern. It's going to help you in your future. Okay, now after 3, hey, let's talk about fourths. Okay, quarters. I like quarters. They help you make a phone call, you know, or, you know, you can call somebody who cares if you have one. Okay, here's the deal. We're looking at, are you familiar with the song? Here's a quarter, call someone who cares. I'm going to get my walker out. Look it up later after notes, will ya? Okay, the fact that we no longer have payphones, a lot of stuff just goes away. Okay, here's a quarter. Call someone who cares. Is one of your assignments tonight. It's a good song. Okay, pi over 4. Are you okay with that? Will I add pi over 4 to pi over 4? I get 2 pi over 4. Hey, pi over 2. 2 pi over 4 is pi over 2. I add another pi over 4. I get 3 pi over 4. And guess what? Another pi over 4 is 4 pi over 4, but that's the same as pi. I got it right here. So I got now 5 pi over 4, that's down here. I got 6 pi over 4, which is the same as 3 pi over 2, so it's already marked. I got 7 pi over 4 over here. And then 8 pi over 4, which is 2 pi. Are you okay with where we're going? Yes or no? Okay, is it making sense? Because this is that stuff that people were like, huh? In that last part on that 13.2 worksheet that we did. Okay, now I've done 4s. I got news for you. We don't do 5s. We do 6s. So we're now going to pi over 6s. And I need black. That's my new color. So now I got pi over 6. And then I go 2 pi over 6, which is the same as pi over 3. I go 3 pi over 6, which is the same as pi over 2. I go 4 pi over 6, which is the same as 2 pi over 3. I go 5 pi over 6, which is almost pi. Less a pi over 6. Then I go 7 pi over 6. 8 pi over 6, which is, 4 pi over 3, 9 pi over 6, which is, gosh, that's 3 pi over 2, 10 pi over 6, wow, 10 pi over 6, that's like 9 pi over 6, 10 pi, that's 5 pi over 3. So that's already there. And then I go 11 pi over 6. Did you notice that the pi over 6s clump around the x-axis? Crazy, right? This is the first part of your education of the unit circle. Okay, the first part. Keep in mind, pi over 6 is the same as 30 degrees. Okay, and people are like, what? Remember, pi is 180. So what's 180 divided by 6? 30. Pi is the same as 180 divided by 4, 45 degrees. Pi over 3, okay, remember pi is 180. 180 divided by 3 is 60. Pi over 2, same as 90. You see where I'm going with how I can connect it real quick? And we won't use degrees outside of us finding measures of stuff. We will use radians for functions, and the function stuff with radians is where it's at when we go to calculus. Being able to recall them fast is going to be helpful. Noticing the connections between degrees is helpful to give you that first step into understanding where radians are located. But I want you to kind of burn the degree ship and be able to work with radians and be comfortable with them. Okay. Now remember, this is all in standard position. I can flip it around and talk about negative 11 pi over 6 is up here. This is negative 11 pi over 6 if I go up this way too. Okay, so just know that. But where are we going to go from here? I'm not going to do a bunch of them, but I'm going to talk about them. First of all, do you guys remember the special right triangles? 45, 45, 90, 30, 60, 90? Remember, this is a 30-degree angle. This is a 60-degree angle. This is a 45-degree angle. Really? And this is called the unit circle. So the distance from here out is 1, 0. I have coordinates for that. And this will be known as cosine and sine. Cosine will be your x value, sine will be your y. Okay? And people are like, what? 30-degree angle. If I go 30 degrees, and I have this as 1, do you remember that you had, this is half of the hypotenuse? Okay? And over here was the square root of 3 over 2, okay? Cosine of pi over 6, or cosine of 3, or 30, sine of 30. If I work it through, I'm going to be working on my cosine and sines and be able to quickly find sine and cosine of 30-degree angles, 45-degree angles, and 60-degree angles, and 90-degree angles, 135-degree angles, and so forth. Calculator free in a blink of an eye, because you'll know this that well. But that's what we're going to be doing in the next few days. Okay? By next week, you'll be able to fill out the rest of this. And there is actually a sheet on your notes that we will be doing. Okay? But get yourself familiar with this, and the best way to do it. Today, I numbered a circle with pi, pi over 2, pi over 3, pi over 4, pi over 6. If you can do that, that's a third of the battle. Okay? So be able to make your own circle without referencing anything else, and just quiz yourself over the next couple days. And then we'll start adding other things to it. And you'll quiz yourself over the next couple days. And then we'll add more things to it. It is one of the issues that people have with being successful on the test for chapter 4 and 5, but it's more so one of the issues they have being successful in calculus using them if they don't know it. Because it is all calculator free, and you cannot rely on your calculator if you advance on the calc. Because parts of that AP test is no calculator at all. Okay? And it's not said because I'm threatening. It's said because it's the truth. So make sure you're ready for it, okay? All right, the remainder of today is this for you guys to get your stuff done.